Okay, this is a rigid body rotation about a moving axis when we have combined translational and rotational movement. So we're going to extend our analysis now to motion where the axis of rotation moves. When this happens, the motion of the body is both translational and rotational. We can understand this by understanding that every motion of a rigid body can be represented by a combination of these translational motion of the center of mass and the rotation about the axis through the center of mass. This is even true when the center of mass accelerates, so it's not in an inertial frame. The kinetic energy of a rigid body that has both translational and rotational motion is given as follows. The kinetic energy, the total kinetic energy, is 1/2 mv center of mass squared, where m is the mass of the body and v center of mass is the velocity of the center of mass, plus 1/2 I center of mass omega squared, where I is the moment of inertia and omega squared is the angular speed. A special case of this translational and rotational movement combined is rolling without slipping. We can view the motion in an inertial frame of reference in which the surface on which the wheel rolls is at rest. In this frame, the point on the wheel that contacts the surface must be instantaneously at rest so that it doesn't slip. So the velocity at this point of contact relative to the center of mass must have the same magnitude but opposite direction as the center of mass velocity VCM. If the wheel's radius is r and its angular speed about the center of mass is omega, then the magnitude of v is r omega. Hence our equation, v center of mass equals r omega. This equation, the summation of the torques of a rigid body about the z-axis through the center of mass equals the moment of inertia of the rigid body about that z-axis times the angular acceleration of the rigid body about the z-axis, is true for both simply rotational motion and rotational and translational motion, providing that the following two conditions are met. One, the axis through the center of mass must be an axis of symmetry, and the axis must not change direction. Rolling friction. If there's no sliding force at the point of contact, then friction does no work. So if the body is rigid and the surface is rigid, then we can ignore the friction.